Today we're going to be looking at vectors, and to do that we need to have a quick look at scalar quantities. Scalar quantities are just quantities that have magnitude or size, so things like time, mass, temperature, volume or speed, okay, all things that are involving size. Okay, and vectors, here we've got the vectors, so they include this direction component as well, so things like force, weight, momentum, acceleration or velocity. Okay. So how do we represent a vector? We represent a vector between 2 points here, A and B, okay, and we use this notation, the A-B notation with the arrow over the top. And the length of the vector represents its magnitude and its direction is represented by the arrow. Here we've got another vector, CD, but this vector CD has the same length as AB and is also in the same direction, so it's actually the same vector. So AB equal to A is equal to CD. Okay, you notice this other notation here, vector A with the tilde underneath, just another way of writing vectors. Here we have vector CD, and we can split this vector up into two different vectors, which are the vector components. So how much left and right is the vector going, and how much up and down is the vector going. So if we have a look at this vector, this one's going right 3 and up 4. Okay, and we can change our notation now to represent that. So we use the IJ notation. The I notation means how much left or right, and the J notation means how much up or down. Okay, so this one's going right 3 and up 4, so we make them positive I plus 4J, which is the same down here as well. Okay, to find the magnitude of the vector, so how long our arrow is, or what's the size of the vector, now that we've got the components, 3i plus 4j, we can find the length of the hypotenuse here of the right angle triangle, so 3 squared plus 4 squared equals 5. The CD notation over here for magnitude, we put it in between two vertical lines. Okay, for vector addition, adding vectors together, sometimes we want to add vectors together to find the resultant vector. So A plus B, and what we need to do is add these vectors head to tail. So from the head of this one, so we're going to move vector B up from there up to the top here, so from the head of this vector to the tail of your following vector, so and add them together, we get A plus B, which is represented by this blue arrow here. In the IJ notation, if A is 3i plus 4j and B is 2i minus j, then our A plus V vector becomes adding the components together. So 3 plus 2 equals 5i, and 4 minus j, well, 4 minus 1j equals 3. Scalar multiplication, so we can multiply our vectors by scalar numbers, so scaling up the vector, making it bigger, or scaling it down, making it smaller, to any value we like. So this one I've halved the vector A, so it's in the same direction as A, but it's half the magnitude. Okay, so in our IJ notation, that becomes, if A is 3i plus 4j, then half of A becomes 3 on 2i plus 2j. A unit vector is having a vector with a magnitude of 1. So if we want to find a vector with a magnitude of 1 in the direction of A, this vector here, which looks like this, we find the magnitude of A, and then we'll divide by its magnitude to get a magnitude of 1. So 3 over 5i plus 4 over 5j. Vectors can be also represented in 3D space. So we've added an extra dimension of space here, this k component. We can find the magnitude in the same way as for 2D. We just add this 5 squared on here. Okay, they become square root 50. We can simplify that third down to 5 root 2. And then if we wanted to find a unit vector AB, we just divide by its magnitude. So we found the magnitude 5 root 2, just divide by that magnitude, and we get the unit vector in 3D space. Now for an example, if u equals 2i plus 5j and v equals 3i minus 4j, find u plus v. So u plus v equals, now we just add the components together. So in the I direction, I've got 2 plus 3i, and in the j direction, we've got 5 minus 4j. So that gives me 5i plus j. To find the magnitude of u plus v, so the magnitude, so we put the vertical lines to represent the magnitude, equals, now we take the square root of the components squared and then add them together. So 5 squared plus 1 squared gives me a total of root 26. Now to find the unit vector u plus v, so the unit vector, so unit u plus v hat, to represent the unit vector, we just divide u plus v by the magnitude. So we've found the magnitude, root 26, 5i plus j. Now that gives a vector of magnitude 1 in the direction of u plus v.